All right, so for the sake of recording, starting a few minutes late today, we had a guest come in, do some surveys, some data analytics work, collecting data. She's doing an old style data collection on pen and paper. That way she can track it as she types it in the paper. One of the things she mentioned is there's still the human component is needed. The machine stores the data for us. It can find any piece of that data really quick, but we still need the human to make sense of it, to figure out what's going on. She had some other good points to say about working in the field of data analytics. There's some really nice things about this field working. But for us, still sort of introducing things. We'll kind of get started putting an example together as we talk about things, because otherwise it would just be one of those list and definition sort of lectures, and those definitely aren't the most interesting. We want to actively do something along the way too. So I guess before we get started, first thing here, I did go through all of the rest of the discussion boards. I didn't get to module 1 when I started in module 2 because I came into the class so late that I just started with the adjustments in module 2. I figured we'd have to be doing stuff before I got them filtered out. But I did go through the rest of the discussion boards and adjust them slightly so that it's there's room for discussion. Like there was one that was explicitly, it gave you 3 terms and said, go find the definition of these. And then there was a requirement to reply to your classmates. How do you reply to that? I see you use the definition from the Oxford Dictionary. I like Merriam-Webster a little bit better. It's not meant for discussion. So I added little tweaks here and there to hopefully open that up for discussion for module 2 on through the end. Still got some more editing to do. So if you like to work ahead, if you're one of those people who likes to work ahead, try not to get too far ahead because I'm still editing those. The discussion boards really caught my eye at first. It's like, these are not good. I'm not a huge fan of discussion boards anyway. It's, but there are some valuable insights to be had from them. Got those corrected. In general, this week we're talking about a few concepts. There's some assignments about the idea of data versus information. We talked about that before. So data or data versus information. So data is going to be the raw facts. No context. For example, for. There's lots of things for could mean, right? Is that the number 4 or the word for? The numerical 4, cardinal number or ordinal number would be the proper terms for that. Is that the number, cardinal number 4, the one we can do math with? Or is that the ordinal number 4 as in 4? And without any context, we have no idea. It's just something the data holds. We need to apply that somewhere. And that's where information comes in. Where the transition from data to information. So useful data or data would be information. Once we grab that, in the case of 4, we grab it and do something with it. We add context to it. So maybe $4 in shipping. Now it's definitely something that has meaning, right? We know what to do with that. We can apply it somewhere. We can compare it to other shipping costs. We can choose the option for free shipping instead. Make decisions off of it. Used in making decisions. And that word right there should trigger our memories of something from last week, right? As we're working through our assignments, we're going to use those key vocabulary terms and all that stuff. And last week we talked about OLTP and OLAP. Usually the one with the A has enough vowels we can pronounce it. We say OLAP and OLPP to help distinguish them. But the raw data itself, that's going to be our online transaction process. That's just putting the numbers in the database and pulling them back out of the database. Purely on the machine. But for once it's information, that's where it's the online analytical process, or analytical analysis, analyze, that human component that our guest was talking about just a few moments ago. She's going to collect all that data, dig through it, make decisions, and come back with recommendations to the school based off the answers to those questions. So online analytical processing, actually doing something with the data, making it useful, making it applicable. It's not just a random number that a computer was able to store for us. There's an assignment about that this week. It's fairly straightforward, not much. Like most of the assignments, make sure you're using the technical terms, looking up things, and applying all the definitions in there. Excuse me. I should put a cough drop in my mouth because I'm barely going to. Oh, and for I had the live session with my online class this morning, or the second one. I usually do several of those. So I remember a whole lot of online classes where I would like to interact with an instructor at some point. So I did one of those. So I had I drank a whole Mountain Dew around 11 o'clock. So hopefully I won't have a caffeine crash halfway through our class. But I'll just drink more Mountain Dew if that seems to be happening. Yeah, the basic idea there. Does anybody have any questions about that difference? Hopefully that makes sense and how we use those words. Really, we can do stuff with the information. The computer can remember the data. And that's going to be the two versions of that. Okay, if I erase those notes and get to our main topic for this week, the one we'll actually use as we're doing stuff. I'm starting with a picture. A similar thing, I'm going to draw a table, but a similar thing would relate to a lot of NoSQL data. Not necessarily all of it, but just depending on the situation. But for the most part in this class, we're going to be using relational databases. Put things in nice rows and columns, spread out. We have the headers. So it's still very similar to the key value pairs like we would use in NoSQL. It's just instead of a key value for every single data point, we have one key and then a whole bunch of data points that go with that key. So we don't have to keep repeating it. That's one that's going to seem deceptive in the classroom when we get to covering NoSQL. It's going to be like, oh, this is great, this isn't bad. When we get up to large data sets, you have to come up with the key and the value for every single data point. And it kind of doubles the work, doubles the workload, which in an example small enough to fit in the classroom or the weekly homework, it's not going to seem like very much. But when you get up to real modern data sets, that's a lot of keys you have to come up with for every single one. And in some cases, leaving empty cells in the table would ultimately be better than trying to come up with a key for every single cell of data that you have. But if we have a table, I tried to draw those roughly the same spot size. Let me see if I can fix my picture. We set that up and we got a bunch of equal spots to store data. That can be a problem, right? We haven't really talked about it yet, but we need unique identifiers on everything. Sometimes it's hard to come up with a unique identifier. So a good fallback is just give everything an integer. Just have the computer automatically count as the records come in. Everything has a, number 1, number 2, number 3, number 4. The computer's counting, so everything has that unique integer. So we could just store that with an integer. That's not very much data. just a few bits to store an integer. So maybe that's only going to take up like that much of of the space we set aside for that column. Same thing here, same thing here. Maybe we have some people's names. That's my normal fallback in class for those who have seen, I mean, a few classes or I think we've already seen it a couple times this week in class. Classroom examples always name, age, and count. So we have some people's names. If we just ask for text, the default's going to be 255. That's what today's lecture is going to be on. We get enough space for 255 characters, which is one thing, and one thing I'll throw out now, and we'll talk about it more specifically later. Currently used to powers of 2, right? 256, which when we number those, we usually count 0 in computers, so that's 0 to 255. I just said we have 255 values. In relational database, the 0th thing is used by the database. So all of our indexing starts at 1 because the 0th one's already used. So instead of 0 to 255 giving us 256 things, we actually only have 1 to 255 that we can use. So a lot of the numbers will seem off from the power of 2, like they're used to. Or some of them will seem off from a combination of powers of 2. We'll see that really, really soon. That's what I said a moment ago. This is an integer. By default, we get 11 bits for that, which is definitely not a power of 2. But it's 1 off from 2 squared plus 2 cubed. So we have the numbers aren't exactly powers of 2 because the database needs some of them. But maybe names. Anybody ever met a person with a name 255 characters in it? That's an awful big name. So we're not going to use much of that. Probably more than just that number, but I'll just draw 3 columns. I think the point will be in the picture here. Then maybe we have something else. Maybe it's a blog post. Right? This person we think of it that way. An identifier, an author, and then a blog post. It could be really long. Right? If we just go with that 255 bits, maybe this person writes 10 pages. Put away kind of that much data, or somebody writes a couple paragraphs and something like that. And hopefully you're seeing a couple problems really quick with just those shapes on the board. Here and here, that's just wasted space. And then here is an overflow. You'll probably recognize that word from an overflow error. And the reason we call it overflow is kind of obvious in just with the random shapes here. Not necessarily an error. Sometimes if we know that's going to happen, we account for it, and that's just an event that our program's the computer's going to react to. It's only an error when it wasn't supposed to happen and causes things to crash. But we know those happen sometimes, so we can account for them. In database, there's generally 2 things that are going to happen when we get an overflow. It's either going to truncate it or fall back to a default value. We're going to see both of them in like very near the beginning of the examples when we're actually doing stuff here in a few minutes. But definitely not the best way to set up this grid, right? A much better grid in this case. Oh. There was a question from that survey beforehand about being hard to see the board. Is that a little bit better? Or you or Charles, whichever one of y'all said that. Hopefully they can see that better. So a better way to set up this table, to show up on the camera, kind of. We didn't need hardly any room for that first column. Then the second one is a little bit wider. And we need tons of room for our third column. Still have the same number of rows, but the data would fit here a lot more better. That's where we get into strictly typed data. We explicitly control what the data is going to be. So our guest earlier came around with a little form. Everybody fills out the same form, right? We talked about structured and unstructured data last week. That would definitely be structured data. Right? Everybody's going to write a different answer, different response, but everybody's being asked the same questions. So every one of those answers can go in its own column, and it's nice and organized, and she has the same answers from everybody when she goes to, or the answers to the same questions when she goes to deal with it. It's not like she just ask everybody to turn in a blank piece of paper and write down your thoughts about the space usage at campus. That would be a very different ordeal altogether. In order to, so we want to optimize this. Empty space can be a big problem pretty quickly too. So by default, I'll write this in red, it's a problem. By default, if we just say we have text data, we can do 255 characters or char. When we cut off the rest of that word, a lot of people just pronounce that as char, which the camera a little. 255 characters. Oh, what's a typical name? We go with the first name. So my name is Christopher, Christopher, 10 letters. Some names are shorter, some names are longer. I filled out many forms where I ran out of room to write all 10 letters in my name, and I don't feel like that's a very long name. And it always bothers me to run out of letters. I always go back to Chris if Christopher won't fit. Doesn't seem like a very long name. Some people have longer names, especially maybe people immigrated from another country where the phonetics they use are different than English phonetics, so we have to add extra letters in there to get the extra sounds, and then Americans still end up pronouncing their name wrong or look at all the letters and just panic. India is a great example. India picked up the Latin alphabet. I'll call it that. They picked up the Latin alphabet when Britain arrived there. So they have their traditional names, but they've only been using the same alphabet as us for what, about 180 years? So every single the letters are all pronounced, and that always throws people off with Indian names. You see Indian names and like, oh, there's a bunch of letters there. But English was put onto their language. The alphabet was forced onto their language. So every single letter is pronounced there. And only 180 years ago, so there hasn't been a whole lot of change. But when Americans see that spelled out, it still throws them off. Even people with Indian heritage, I've seen that happen as well. People from India or Sri Lanka that are like second or third generation in America, they see somebody's name from back home written, and it throws them off the same way it would other people. So some of them might be longer, but I'm going to use the length of my name. 10 seems a good one. Some names are shorter, some names are longer. So we only need 10 characters to our name. That means we have 245 extra characters. Those characters are Unicode. Put a note there. Unicode is 16 bits. And we can assume 245 extra characters seems reasonable. So 245 times 16. All right, we can pull out a calculator, punch that in. I'll use the calculator here. We can do it by hand, but we have calculators, right? It's modern world. Calculators never make little errors. 45 times 16. So we have 3,920 extra bits. .9 kilobits in every name that we try to store in our database. When we talk about bytes, what's that divided by 8? Let's turn that into bytes. 490 bytes. In every single cell. Let's go with Indiana. 6.5 million people. We might have had 6.6 million. I haven't checked the numbers lately. But 6.5 million people, and we're wasting 490 bits in one column of that table. Every single cell. Times, whoops. 490 times, not an 8, 6,500,000 people. That's a lot of wasted bytes that we would never really need there, right? And that's what the main point of today's lecture is going to be, that wasted space. So there's our bytes, kilobytes area, the megabytes. So 3.2 gigabytes wasted just because we left too much room to enter people's names. And data sets get a lot larger than the population of Indiana, right? There's way more people in the world than just Indiana. If we multiplied that, well, y'all could multiply that by 7 billion and see how much data we would be missing, just in that simplified example. And that wasn't even counting this wasted space here, or the lost data over here where we had to truncate, where it got truncated, or the overflow default. So that's the main thing we want to look at today. It's okay if I erase the pictures, start to listing out what we're actually going to talk about then. So it's important to, especially with the structured data, we know what it is. So we can put that thought in beforehand and put together that type we want to use. Okay. Why don't we just do this in database? Let's actively do this and look, because so I'm going to share my screen and pull up one of those databases I said set up. Did everybody get a database set up just to play around with and do stuff? I'll use the one on Jamf. But again, the one I went with is probably the most popular combination you'll see, because this is what WordPress, which is a popular way to drag your mouse around, make a website without actually writing the code. The most popular one, this is the setup they recommend. So then all the other ones like that kind of need to recommend the same setup as WordPress, or they're not going to work. Their stuff's not going to work on a typical domain host. So most any free domain hosting site will have this setup, an Apache server and in particular, MariaDB version of MySQL. When he made MySQL, he made 2 of them, named them after his daughters. MariaDB is the proprietary one. Costs money, but that's when you go file taxes for your business. That's an itemized deduction, business expense. MariaDB is the open source version. So they're very, very similar. And they're modeled after the Oracle database. So some of the notes in Ivy Learn might still be referring to the Oracle database that was originally going to be used, but my name ended up as the instructor for this class at kind of the last minute. So I didn't have a whole lot of time to get ready after the adjunct moved on or adjusted. What happened is that up in South Bend, in case anybody was curious, you saw the other name on there. Up in South Bend, there was a high school teacher that one day finally threw down his marker and walked out of class. So the dual credit classes and 3 dual credit classes in South Bend were, they could not find an instructor for. And one of our adjuncts said that he was willing to take it. And so I moved. So he's teaching those high school classes virtually, and then I just put I'm the department chair, so I put my name on there to cover the class. But that was a big need, right? Three high school classes in a fairly large city is a lot of students that needed, and it was the dual credit. So it's also the students that were supposed to be getting college credit on their way through high school. It was affiliated with Ivy Tech. So it was a big mess. That's how I ended up in here, teaching the class instead of the person that was originally on there. I was adjusted at the last minute, and I'd always planned that if I was going to teach the class, I'd have 3 or 4 months to review Oracle beforehand, because I know it, but I don't regularly use it in my own projects. So with that, the one that was probably the most common database we'll see anyway, and that's what I always use in my own projects, so I know I can answer questions off that off my head. But essentially, it's a very, very similar. It's one that was based off of Oracle. There's some slight changes. It was made 15 years later. So when I say based off of it, it's like, oh, we can make this easier and make these little adjustments after the 15 years of experience that we have to look back on and see what didn't work so well that first. Is where MySQL comes in. People see MySQL all over the place. That's one of the big ones. So localhost was using the local server and /php by admin should take us right into that database or the interface for it. So I'm going to go over here and create a new database. So if you're using the domain host, they probably set the database up for you and you just add tables to it. Here locally, you need to actually create this. Oh, what are we on? We're on types. Data type. Types. Seems like a good name. So go ahead and create a new database to start working with. So first thing it's going to ask is, okay, we want to create a table. How many columns do you want in? And this is kind of like that setup from those pictures I erased. We set up everything ahead of time so that we know what it's going to be. Let's do 3 tables. Maybe this is, I'll work away from the normal example. Products, that's a good start. We'll have a little like sales situation. So I'm going to do a couple tables, so we'll come back and see the normal ones as well. But something with 3 columns. We haven't really talked about IDs or anything yet. And okay, create and get started making this database. And you'll notice here on the GUI, there's a whole bunch of things to fill in. So what do we need for a product? We need a name of the product, a description, and a price. That'll get us like an online sales, retail sort of thing, right? But what type of data are those? And I decided to start in the GUI because there's nice, all of them are listed out. We can look at them and see what they are. So right off the bat, there's that short list, the predictions. Okay, if you have some data to store, it's probably one of these 4 things. That's what people seem to store the most often. Name, we go down, there's numeric, we'll come back and talk about numeric. Date and time, we'll add that in. We do our customer tablers. Somebody first become a customer and then they get a special sale price for the first 90 days they're a customer. String, that sounds like it worked for a name. So alphabet text. Oh. Hovering over, oh. I thought text was 255 characters. So I was a little bit off on that. So that thing earlier where I said we waste, remember what that number was? It was like 3 gigabytes just on that name column. It was 2 to the 16th, not 2 to the 8th. So way, way bigger data set that would just be wasted if we chose the wrong size. For a name of like a simple sales thing, like the examples when we put that in here, I was thinking of things like hammer, chair. We definitely don't need 65,000 characters to store that. Tiny text, that's the one I was thinking of earlier. 255 characters, that's still a lot, right? If we're just gonna have the name of a product on an online retail thing, it's probably names like hammer, chair, only short names. So we probably don't even need to go that long. You saw how long regular text was. We get up to medium text and long text. Basically up to 4 gigabytes of text. That's a lot of stuff. And there's more down here. Probably won't use them much in this class. Blobs are something I use a lot, especially programs where you put your code into the database and then you have a GUI that runs queries and it makes it look like your program does a lot, but it really only does one thing at a time. So it always runs super, super quick. Doesn't fit in classrooms well for software development lectures because it's time consuming, but it's very productive. Blob is binary large object. Just take your binary code, throw it in the database. I've done databases where every column is, and it worked fine. But for the classroom, we need to talk about proper form and the correct way to set that up. So we probably won't talk about blobs much, but that's just binary large object. So for those who are software developers, that's an immensely useful one. Just whatever you have, the computer knows it in binary code, just throw it in this blob. We don't want something specific. Tiny text is probably even bigger than what we need. We don't need 255 characters for names of a few products. Char, well, that looks like up to 255. So we would set the length of it. So we'd say like char 32. And now we have 32 characters to put for every single thing in that column. But we can do even better than that. Because maybe some of them, hammer, chair, pan, some names are going to be shorter than others. So we're gonna have wasted space, or we could end up with something with a long descriptive name that takes 34 characters. Just so for some reason or another. So char gives everything in that column the same amount of space. But right below that is the one we really use the most often. Varchar, or variable characters. So this one, every column automatically adjusts and the computer will keep track of the width of it. So our pictures would be wrong because we're still going to draw the table with nice straight lines. But really the size of those is going to change. And that's the optimal way to put the strings in there. And then we give the upper limit. Does it say that? Yeah, 0 to 65,000. And it's variable length string versus char, which is a fixed length. So usually we'll go with varchar and then put in our upper limit. So, and the computer will automatically figure out how much space is needed there without wasting anything. We just talked about strings. Anybody have a good thought on what would be good for the description? Here's a hint. If we go up to the top on the short list, only one of those made the short list of things we use most often, right? That's the one you usually want to go to because it basically asking the computer to optimize the column size or the cell size to not waste data and then have a calculation like we did, which again, I was a little bit off of because I thought text was 255, but plain text is 255. So we need to multiply that by a much bigger number that 8 bytes we were wasting in every single 8 gigabytes we were wasting. Multiply that by like another 30,000 or so. That's a lot of data that's just empty space because we don't need that. Most often I'm going to go with varchar. A description is going to be longer though. We might have a nice size paragraph. I'll do 255. Just go with that number. For this first table, what about price? What's our best way to do price? If we look at our list under numeric, we have, well, we can automatically rule out these up at the top, right? Because price isn't going to be an integer, at least not in America. And we know we're going to have a floating point number. But as you hover over that in PHP My Admin, you should see the little pop-up box tell you how big the thing is. And just kind of plan accordingly. Notice hovering though, all of them do have negative and positive numbers. So we don't have just an only positive integer. So whatever one we use, all of our data types for integer have both positive and negative integers. So we get down here. Real number is kind of like text. Real is just say we have some sort of floating point number and it's an alternative way to use float. I thought I put something in my notes, but I don't have a good explanation on why they have two floating point numbers. Floating point numbers, so real is the equivalent to that. If you check the math on it, a fairly large number. But if we go to double, that's double precision. So you notice float is to the 38th power. A really big number is 64-bit number in MySQL, which is going to be different than a lot of your programming languages. So if you have a script that runs that, there's a good chance your script, what your programming language that's pulling data from a database calls a float is not the same as what MySQL calls a float. So you always want to pay attention to those numbers. And double precision floating point is just more accurate. But you'll notice that to go from 1.2 basically to the times 10 to the 38th power is a really big number, but then the double precision is up to 2.2 times 10 to the 308th power. So it's way more than double the precision. Back in the 1970s, when they first created relational databases, then it was nice and double. It was a 32-bit number and a 64-bit number. But as computer hardware has grown, that's just scaled up automatically, and they've set our size bigger. One thing you'll probably notice is that we don't have like the char and varchar. We don't have anything with variable size. All of those are fixed sizes. And that brings us to the last one on the list, which I probably guess this is the one we want to use. And I do want to make a note here. So Oracle and a lot of the reference material that could be built into the course shell that I haven't completely dug through all of it yet. Oracle called it number. And then by 1995, when they were ready to update it, when MySQL was coming out, they decided to go with decimal because it refers to our places. So in Oracle, we call it the number type. And it's actually a function we'll pass in two parameters. For MySQL and others, so these are just two alternate ones, we'll call it the decimal type. And then we pass in two numbers. The first one is the length of our number. So number of digits in total. And then the second one is after the decimal. I'll write a D. That sounds like a good letter to use for that. The number of digits after the decimal point. So am I still on board? Yeah. All right, decimal 5,2 would probably be good for a price because we have 5 digits and 2 of them are after the decimal. So that would give us something like that. I'll plug in the digit for the pound for the number sign there. Right. 122.45. Or if we only have 4 digits, like 1999, 19.99. It gives us that form. So the length of it, and then how many of those digits fall after the decimal. That's very similar to the varchar, only we kind of have to know what numbers we're plugging in there. Let me jump back over here. Price. Let's say it's decimal format and length values. I'm not used to using the GUI. I think I plugged both of them in here. Next thing I was going to show will be useful for that. So like 5,2. Let's see if that works. Yeah, I'm used to the code, so I'll go type it in. But do those data types make sense for a small sales table? Some for an online retail? I see heads on, yeah. You want to think about every type of data you're putting in, all that advanced planning. Because then it's collecting the data and plugging it into the database. And that's easy, well, relatively easy. Our guest earlier said she's been to 19 Ivy Tech campuses recently, so she's probably put a lot of miles on her car, talked to a lot of people. They're spread out all over the state of Indiana. She probably doesn't know every single road around the state of Indiana. Or where construction is. I haven't made last time I had a meeting in Indianapolis. GPS was just giving me nonsense, or Google Maps was giving me nonsense, so I didn't even bother looking at GPS. I started contacting people in Indianapolis and like, how do I get to the main Ivy Tech campus? Because yeah, if one map is giving nonsense, they're all interconnected. So surely all of them are going to give nonsense. Like one of them had me go through the parking lot of Ivy Tech, 7 blocks north, and turn around and come back. That was the second route. I thought the gray one's the second route, right? Yellow's the main route, and gray's second. So Maps was giving nonsense like that, sending me down one-way, things that I knew were one-way streets and.
Yeah, sometimes they make it hard to know where you're going.
Yeah, so there's things like that in the data collection, but, once we do the planning, we can plan ahead for all the data we're gonna have.
It's even harder when you go off on the off-trail road that is a road but isn't on the map.
Yep. There's, a lot of things. And notice this button right down here, preview sequel. So ultimately, this is the instruction we could just type in. By the end of the semester, we'll just type that instruction in. So as you use the GUI, and that's all over PHP MyAdmin, that's one of the reasons I wanted to use that in class. Because Oracle Apex does not have a GUI alternative. Or there are some GUI features, but it doesn't have the complete GUI for MySQL, or Oracle's version of MySQL. And yeah, MySQL was an update on Oracle, and then Oracle updated MySQL. And so it's not the same Oracle that we were talking about the other day in the history section that was created in 1979. It has been updated and improved a lot along the way. And after MySQL based their stuff off Oracle, Oracle rebased some stuff off the improvements in MySQL and improved the Oracle database along the way and still call it they call it MySQL. So MySQL is like a category of databases, not a single thing. This word right here, the one I pointed out on the board, I mentioned one the other day, auto increment. We will see that a lot later. That's the first SQL keyword I look for to try to figure out which flavor of SQL I'm in. This one right here, number or decimal, or I don't want to throw up a much longer list right now, but whatever that, where we control the size of the number, that's the second word I look for to figure out which flavor of SQL I'm in. Because SQL is an entire category of languages, and unlike our regular programming languages, they did not all get independent names. They're all called SQL. So if you're handed some SQL code somebody else wrote, you have to figure out which particular SQL database that is. Structured query language. It's an entire category, and nobody bothers to name each individual language. So there is that. It's not bad. They're all very, very similar. Like, you will not find one that does not have create table as the keywords to create a table. Going all the way back to the early 1970s. There's some extra stuff in here that we don't necessarily need to get to, but you can preview your SQL that way. And then there's going to be a button that says go on everywhere in this interface. You hit that to run it, or Control Enter runs your query. So we use the GUI to put together a query. So if we hit Control Enter, it should run that query. But it didn't run. Oh, maybe not. Let me hit go. I've never used the GUI. Control Enter works when we get to the SQL one. Sorry, I thought it worked here. I could have swore that's what I did when I was getting ready on Sunday. Let me just try hitting save. Okay, save. Actually runs that table. I'm sorry. I could have sworn I hit Control Enter like I do on the query, but maybe I did that and it didn't work, and I forgot what I did afterwards. So notice it created this table. If I come back up to the top level of this, so here's our database. Shows we have a table in there. Just about every word here is a button we can click on. Some of this stuff is just words you can see from the cursor, but pretty much everything on the screen, 90%, 99% of the stuff on the screen is a button to click on. This particular GUI, web-based GUI, does have complete control over MySQL database. And there's a lot of buttons in there, so try not to get lost in there. It gives us our table. If we click on that, we can go in there. We need to insert some data. We'll do that next. You can see our columns don't have any data in them yet. That's the next step. Come up here. There's also an alternative GUI. If I come over here, Notice it drew this little picture here. This is the entity relationship diagram for that table we just created. So you're gonna have a number of assignments where you are submitting me an entity relationship diagram. And for those who've had software development classes, you probably remember doing UML class diagrams. We draw those pictures, but the picture doesn't require any thought whatsoever to put together. Entity relationship diagrams are like that. If we have our table already made, it's used in a planning thing, so often that's what the database designer is going to sit there and think about. They're going to draw that while they're doing all the thinking, and then use that to create the table. But if the table has already been created, it doesn't require any thought to create the ERD from that. So for your databases, you can generate an ERD, but for the assignments in this class, please go ahead and draw it by hand. And I'll put quote marks around hand. Obviously, we're going to use software specifically designed to draw ERDs, not on pieces of paper, unless you just really like drawing on a piece of paper. Send me a picture of it, that would be fine as well. But please draw it yourself instead of using the generated one for now. But in the long term, that is something that can just automatically be generated. And you'll notice over here in the diagram, we have things like a create table button here. So you can do it from the diagram here if you wanted to. A bunch of buttons to look at here, but that gets us a table. The first little bits and pieces about data types. I'm very much a fan of actively doing things. I had some notes to write on the board, but this is more the way I'm comfortable with it, because we learn by doing, right? So we're doing the examples, follow along. That's how we're going to learn stuff. So we need to put some data in this table, but it's probably time for a break first, right? And then we'll make another table or two to look at other data types. And then it's not quite as boring as the notes I put together, which were a bunch of definitions and things right on the board. Y'all can see that, y'all can refer to the definitions when we make databases, right? See what they mean, or we have that hover text. Does 10 minutes sound good to everybody? I see big head nods here in the class. Thank you all for showing up in class today. I apologize for that last minute thing. That was scheduled when the adjunct was the instructor for the class, and I forgot until the calendar gave me the 24-hour reminder. But it was a good example. It relates to our subject, right? Collect the data. She's going to do stuff with it. She said that she's going to collect the data, and then the computer sorts and filters the data, organizes it. She's still making the decisions and the recommendations that she's going to come back to the school with after she gets all the data collected and analyzed and all of that stuff. The other ones, I will try to make sure there's at least 5 days notice. I can tell you when 2 of them are right now, or let's take a break first and I'll tell you when the 2 I know about are. So my laptop says 2:08. We will get back to it at 2:18. See y'all in just a moment.